talking about well-control challenges. Now we're going to talk about the problems, the challenges that we may face during circulating out a cake out of the well by any of our well-control methods, as we discussed earlier. So let's have a look here. We have many challenges. We may face shock washout, shock plugging, hole in the string, loss circulation, nozzle blown out or nozzle plugged, or pump failure. And we have already, during our simulator training and simulator exam, we have simulation, like we have a real influx and we need to circulate it out of the well. So we will face one of these challenges during circulating out of the cake, and I need to see your reaction. What is your first action, and what is the best solution, and how to deal with the situation? So here, once we face any of these challenges, our first action to take is to shut in the well immediately without any delay. Okay, guys? Here, if you look here for shock washout, for example, how to detect it, okay, or how to identify it. First, you will find casing pressure decrease. Then after a lagging time, you will find the drill pipe pressure decrease also, okay? So also, there is always lag time, something called the lag time. This lag time, the time you take to have the same change from casing into drill pipe, and it will equal 1 second for every 1,000 feet. So if we have a well TVD 5,000, so for every 1,000 down, we have 5 seconds, and 1,000 again up, so we have another 5 seconds. So the summation will be 10 seconds, okay? So here, shock washout will find that casing pressure decreasing first, then drill pipe pressure after lagging time started to decrease. And of course, bottom hole pressure will decrease also, but bed level will stay the same. Here for shock plugging, you'll find that the casing pressure started to increase first. Then after lag time, you will find the same increase on the drill pipe pressure, lagging time. Then here, same thing, you will find bottom hole pressure started to increase and bed level stays the same. If we have hole in the string, so we'll find drill pipe pressure decrease, but the other parameters will be stayed constant. Casing, bottom hole, and bed level will stay constant. Only the drill pipe pressure will change. For loss circulation, you will find all of these parameters will be decreased, okay? For nozzle blown out, you will find only the drill pipe pressure changed to be decreased, but the other parameters will be stayed constant. For plug, same thing, you will find that the drill pipe pressure increased, but the all parameters stayed constant. For pump failure, you will find that your stroke per minute, your pump rate will be 0, your drill pipe pressure decreased, casing pressure decreased, and bottom hole pressure also decreased, but bed level stayed constant. Okay, guys? So once we face any of these problems or any of these challenges, we need to take a correct action or first action. So our first action in this situation is to shut in the well immediately without any delay, to give you some time to can handle the situation and take your correct action. For example, if we have shock washout, we need to shut in the well immediately, okay? Then closing our HCR, then go to the backup chuck. Okay, guys? Clear till now? Okay. Coming to talk about the unconventional method, the volumetric method. So volumetric method here, if we found any of these cases, number one, our pipe of bottom, okay. Number two, drill string or bit has been plugged. The drill string is out of the hole completely. Washout in the drill string have been cut and left in the hole, or any equipment failure like pumps or motors. So we're gonna use volumetric method as we are at bottom and no way to circulate from bottom. So what is the volumetric method? Okay, volumetric method is to allow your influx or allow your gas influx to expand it in the annulus side, okay, while bleeding from the choke, while keeping the bottom hole pressure closer to the surface. So here, have a look on the description. Allow the gas to expand to the surface by bleed off amount of the mud from the choke by holding bottom hole pressure closer to the formation. Here, casing pressure will allow to increase to compensate for mud bleeding from the well till gas at the surface. Then start to lubricate mud and bleed gas from the well. Okay, guys, this is all about volumetric method. So volumetric objective is to make gas reach to the surface and keeping bottom hole pressure closer to be constant. Okay. After that, well, starting lubricate and bleed method. So what is the objective of lubricate and bleed method? Here, you look here, it is closed cycle or closed loop. Here we have an influx, this yellow color gas, and we need to control the situation and killing the well. So how to do this? Start from kill line, adding kill mud, and from choke line bleeding the gas or bleeding the influx. So it is closed loop or closed cycle. Here, the method consists of circulating a new mud through the kill line with the return to the choke line in a closed system with control of volume in the tank, while percentage of the gas exits the separator. So the volume of the gas that exits is replaced in the hole with the new mud. Okay, guys, this is for lubricate and bleed. Clear, guys?
Yeah, it's cool.
Okay. Now it's time to talk about bullheading. So what about bullhead? Bullhead method is to pump into a shut-in well, and this method is usually used in well intervention jobs. While well intervention jobs or drilling, we may face a toxic gas like H2S. So we need to pumping this H2S again back to the formation. So we're gonna use bullheading method. Bullheading is to pumping into a shut-in well to force the formation fluids back again into the formation without cause any friction. This way is used especially with toxic gas like H2S. Now, it's time to talk about stripping procedure. We're gonna discuss it more and more tomorrow while talking about the equipment used for stripping like drill pipe safety valve and IPOP, inside blowout preventer. So here we need to run the pipe into a shut-in well to get below the influx and circulate it out of the well. So we need to install IPOP inside blowout preventer or non-return valve above all openings of safety valve in open position, of course. Then stripping will be from annular POP to ram, fixed ram, or from fixed ram to fixed ram. No place for the variable bore ram and stripping operation. So we cannot make stripping from variable bore ram to fixed bore ram. Then here we need to fill up the string, okay, every stance and bleed closing from the choke through the stripping tank. Here casing pressure increase while strip into a gas bubble. If hold constant, bottom hole pressure will decrease. If you look here, this what we mean. If you're gonna strip into a gas bubble like this, here small height, once stripping in the gas bubble, so the height increase and the loss in the hydrostatic pressure will increase. Here, formation ballooning, you look to this figure, descriptive figure, while pump are running, so we have APL, annular pressure loss effect. So fluids go to the formation. Once we lose the APL here, pump are off. So for fluids back again to the formation, this is called formation ballooning. How to detect it? Here, when bottom hole pressure is slightly is slightly, okay, slightly greater than the fracture opening pressure due to the effect of annular friction pressure, APL. So here, losses while pumping fluids due to the effect of APL go to the formation, and the gain while pumping are off. Flow return decrease with time, and bed gain amount equal mud loss. Bed gain equal mud loss. So this is indication of ballooning, but how to detect? First action here is to shut in the well, check for pressure. Shut in drill pipe must equal shut in casing pressure and bed gain. Okay. Then start to bleed 50 gradually from drill pipe and casing. If no build-up, so this is ballooning, you need to circulate through the choke. If there is build-up again, so you need to prepare to kill the well. Now we have another key definition called kick tolerance. So what is the definition of kick tolerance? It is related to the maximum amount of the gas influx for a given kick intensity that you can take at the bottom and circulate it out of the well without breaking the formation at the weakest point. So kick tolerance, how much kick you can take and circulate without crack the formation. Okay, guys? So what is the kick intensity? It is the difference between the maximum formation bore pressure and the planned mud weight. As long as there is large difference between the planned mud weight and the formation bore pressure, so the kick volume you can take will decrease. Okay, so here when kick intensity increase, kick volume will decrease. If you look to this figure here, kick intensity increases, so kick volume decreases. So if we took a reference for 0.5, so we'll find at 0.5 we have only kick volume to circulate without fracturing, about 7 parallel. But at 0.1 you will find we have about 17 parallel. So you can imagine the difference, the large difference between small kick intensity and high kick intensity. Clear, guys, till now?
Yes, it's clear.
Clear.
Okay, now I'm going to talk about the top hole section and problems that we face during drilling the top hole section. It is always related to the shallow gas. So the best practice is to drill pilot hole. Start with small diameter, then start to increase that. Use diverter, of course, instead of BOB in the various section or the coming section. You need to control your rate of penetration to minimize the cutting in the hole. Then use viscous sweeps instead of weighted belts. Then high circulation rate during diverting the gas during out of the well. Also use float in the string to prevent any backflow from the drill pipe. Pump out of the hole while you are tripping out. Here, gas hydrate. If you heard about gas hydrate before, it is something like ice plugging. Ice blocking causes the plugging for flow lines, prevent the flow in its direction. So to forming gas hydrate, we need to have relative high pressure, relative low temperature, water, and hydrocarbon gas. All of these 4 parameters need to be existed together. 4 parameters. If we remove any of these 4 parameters, okay, eliminating any of these parameters, so gas hydrate didn't be formed. So how to prevent the gas hydrate if it's already formed? Here, to reduce pressure if possible, to raise temperature from heating or flowing in a production phase, use injector chemical inhibitors like methanol or glycol. For most well surface well intervention, pressure control equipment test. For testing in general, we use instead of pure water, we're gonna use a percent 50 to 50 with glycol, water glycol to prevent hydrate formation. Our last thing with us today is talking about safety drill and crew training. We have many drills to ensure the crew is able to effectively recognize and deal with different situations like a kick, like a tripping, like a diverting, like choking, how to deal with the choke. So here we have pit drill, trap drill, choke drill, diverter, and POP drills. Okay, ensure the crew is effectively recognize and react to kick when drilling or tripping. For diverting the gas away from the rig, it's called diverter. For understanding how the choke reacted during kill operation, it is a choke drill. Do you perform safety drills in your rig site, guys? Guys, do you perform safety drills?
Yeah, of course, we are trying to do our best.
Okay, good. So now it's about to finish our second part of PMP, principle and procedures. Okay. So have you any questions now? You have any question, guys?
No, thank you.
Okay. So now we're gonna finish our first part. Our first part of principle and procedures. Okay. And we need now to have some practicing. Okay, we need to have some practicing if you have time for our PMP part. Okay, we have our exercise book have about 30 calculations. This is very important and will come in the exam with S numbers. You already solved the cal sheet. Okay, and for sure the cal sheet related to the IWCF exam and the typical like that one come in many times before. So now it's time to have a practice on something related to drilling problems. So please open your quiz book. Guys, open your quiz book, please. Let me share with you again quiz book. Okay.